We are going to continue from where we left off in the last video, which is the fifth exercise. Here we have to fix an error which is going to be about overflows. So we are trying to add 8 to 251, but both of these are in unsigned 8-bit integers. That is, this is going to be adding two numbers, something like this, u8 and u8. This is going to overflow because we know that in unsigned 8-bit integer, the maximum value you can store is 255, and this is beyond range because it is going to be 257. So in order to fix this error, we have to decrease the value of 251 here. So firstly, let's try to run this program, and I'll show you the error. And this arithmetic operation will overflow. This is the error it gives, and it is exactly showing us what we actually found out, that this is going to overflow. So let's quickly fix this. 247, and now 247 plus 8 is going to be 255, and this is going to run. But then the next problem is with this particular statement. If we check the error here for the second variable, this is also the overflow error, and here we are adding 251 to 8 in an assigned 8-bit integer. So obviously this is going to overflow because the maximum value for this is going to be 127. So if we have to add 8 to something, it should be 119 to give the maximum value that can be stored in this particular type. So let's run this, and this is going to compile fine. This particular function tagged add is going to add these two, but before that it's also checking that is it overflowing or not. In case it overflows, this is going to panic. And let's say if it is not overflowing, then this unwrap, what this is going to do is return the value of the sum, because this is something that we will study in enums, that what checked add returns is a result. So either there is an error that we are not able to get a proper result. In that case, this is going to return none or something else. And if there is a result, this is going to return something like okay, and the value, that is the sum of this, which is going to be 127. And dot unwrap is going to return you this particular 127. So if you don't understand this, we will try to do it when enums comes. So it's okay, we can move on. This is interesting because what we are doing is trying to add certain numbers, but here not just in decimal, we are representing number in hexadecimal, in octal, and in binary. So let's run this program and see what the error is. Probably it's going to sum this and then check it with this, and it is going to produce the wrong result. And that is exactly what this is doing. Assertion failed. So if you know about this, before this, let's see what this underscore is. So in Rust, if you have a really long number, something like 1000000, what you can do is separate this with underscore. Now this is more like a million here. Commas would have been used in our day-to-day life, but this is programming, so Rust chose underscore. This underscore is going to get ignored. But anyways, let's solve this. This is going to be 1024, and hexadecimal FF is equal to 255 to the best of my knowledge, and the 77 in octal is going to be 63, and this is going to be, I think, 255. Yes, this is 8 bits. Yes. So in total, this is going to be 4 plus 5, 9 plus 8, 17. The unit digit should not be 9, it should be 7. And the 10th digit should be 2 plus 5, 7 plus 6 plus 5. This is going to be 9. This is 10 plus 2 plus 2. Yes, it's going to be 15. So let's run it. Yes, so we were correct. The next data type is a floating point number. We have F32 and F64. 32-bit floating point number and 64-bit floating point number. 64-bit is going to be more precise as compared to 32-bit. So we have to fill the blank to make it work. I think this is talking about this particular blank. But before that, what we have here is a number, and we know that this is going to get ignored, and this is also going to get ignored, and this is the number that will be stored in X. It's asking what is the data type of this. By default, Rust will make it F64 and everything is fine here, and we are trying to assert the type of X with something, so we have to say F64 here, and it is successful. And we have seen this particular function in the previous video also, which is doing nothing but returning you a string, and the string is the type of t, or the type of the variable. The next exercise is about comparing floating point values. If you know, in computer science, it's really problematic when it comes to comparing values that are floating point numbers, because floating point numbers are not precise. So let's run this program and see what the error is. And exactly that is where the error is, that even though we know that this should be something like 0.3 equal 0.3, this is not going to work because of precision errors. Now what we can do here is we can move this particular number to the left hand side. This is going to be negative 0.3, and remove this from here. And instead of checking equality, what we can say is that we will check if the number 0.11 in bracket 0.2 0.1 plus 0.2 is less than equal to 0.001, and we know it should evaluate to 0, but it is not going to evaluate to 0 because of precision errors. And another thing we should do is remove any negative signs if there are. So let's remove the negative signs. We will use a function, a mathematical function that we have, that is absolute. Let's see if it works. It doesn't work. So the problem is that it is not able to figure out what the type is. So in order to give this a hint, let's make one of them as F64. And what will end up happening is these all will be represented as F64, and I hope it works now. Yep, just to explain you, we did nothing new here. We just specified the type of one number. Now it could have been F32 or F64. So Rust may be getting confused when this function is run. So we made the type of one number to be explicit. The next topic is range. This is an important one. Whenever we are iterating over a couple of values, maybe we have to run something a couple of times, you would want to generate numbers. In Rust, we use ... to make a range. So a range would be something like, let's say if I say 1.5, what it is going to do is produce numbers from 1 to 5. 1, 2, 3, 4, but not 5. 5 is not included here. Just erase this and see what the exercise is. We are trying to iterate and sum over the values I, and I is going to go from -3 to 2. Now let's calculate what it is going to produce. The range would be from -3, we know, then the number would be -2, and then -1, 0, 1, and 2 is not included. So let's sum these up. There would be -5 here in the sum. So we are comparing it with -3. This is obviously going to throw an error. Let's fix this, and this is going to be -5. Let's try to run this now, and it prints. Yes, it doesn't throw an error. Here what is happening is we are iterating over the alphabets of English language. And notice something here, because we put an equal to here, Z is also going to be included here. So what we learned is that if we want to include 2 also here, we have to put an equal sign here, and this is going to run from -3 to 2, and then it will sum to -3 now. Now you would say, how is this possible? How we are producing these alphabets? The way it's doing is it has maybe a Unicode value behind the scenes, and it is incrementing that Unicode and getting the next letter. Let's run this now. It should print success. Okay, it's not going to print success because we are printing alphabets. Again, if we remove this equal sign, we should not get Z in the output. Yes, we did not get Z in the output. The next exercise, now we are producing a range from 1 to 5. What is this? So this is a struct that is going to produce numbers from 1 to 5. 1 to 4, not 5. All right, so I have already opened a tab for what range is. In the documentation, range is a struct. It is similar to that dot dot operator we have here. So this is going to produce numbers from 1 to 5, 1 to 4. So 1, 2, 3, and 4. Now range inclusive means that it's going to include 5 also. If you want to see in the documentation, let's see it. So I think I have to search it. So here, this is going to be similar to this particular range inclusive is similar to this particular syntax. This is going to produce range of numbers from x greater than equal to start to x less than and equal to end. So it's end is included here. Anyways, so here what we have to do is go to 5, but also include 5. And now run it. It should print success. The last exercise is your homework. This is a very interesting exercise. For example, we are subtracting -2 from an unsigned integer. What is going to happen? You tell me after you run this exercise and try to fix it. Another interesting problem they give is they divide 9.6 from 3.2, and the result is 3.0, but this throws an error. What is happening here? Try to find out. And these are bitwise operations. You can see, you can have a look at them. If you get stuck, they have provided solutions, so you can look at them. And that is pretty much it for this video. In the next video, we are going to start characters, bools, and other data types. Thank you.